Okay, so today we worked on kinematics word problems. We're going to review the guess method real quick. You should have a worksheet that looks like this. This is assignment 33 and 34. So we're working on the left side of it. Okay, first what I want you to do, spend about a minute or so, pause this and see if you can match up these units with the letters over here. If it's velocity, put a V. If it's acceleration, put an A. If it's distance, put D. And if it's time, put a change in T. Pause it and try it. Alright, so here it is. Meters per second, that's a distance over a time, that's a velocity. Meters per second squared, that's a distance over a time squared, that's acceleration. S is second, it's a unit of time, so change in T. Kilometers per hour, that's a distance over a time again, so that's velocity. Kilometers per hour squared, distance over time squared. Meter is a unit of distance, so that's D. Kilometer, unit of distance, that is D. And miles is also a unit of distance, D. Okay, and I'm using the symbols or not the letters in front. All right, not using these. Use these instead. Okay, cool. Now, down here, you have givens in a problem that are not going to be given necessarily. They're things you can assume. Like if I say I drop somebody from 10 feet, and their initial height is 10, you can assume that the final is 0 feet without even having to be told that, because it's an implicit, implied given. So I want you to take about a minute to determine what you can assume if you see these things. And here's an example. Okay, so do I have acceleration? Do I have negative acceleration? Is my velocity initial 0? Is my velocity final 0? Is this asking for time? Is this asking for distance? Right? So this is what I want you to do. Pause it and try it out. Okay, pause it and try it out. All right, from rest, that means your initial velocity is equal to 0. That means you started from rest. Okay? To a stop, that means your final velocity is 0. All right, you've stopped. Speeding up means you have acceleration, positive acceleration. Slowing down means you have a negative acceleration. This could be like hitting the brakes or being slowed down naturally, right? How long? This could be distance, if you're asking about how long the runway has to be, or it could be time, like how long did it take? Let's go with this, or it could be distance, right? But how far is definitely distance, right? Okay, good. Did you get all these right? Did you get all these right? Hopefully. If not, you're going to refer back to this in a little bit. Okay, now, you've learned how to read units and symbols, right? If we know the unit, we know the symbol that goes with it. We've learned to imply things. Now, the next thing we're going to do is we're going to apply this to a word problem. Okay? Go through, pause it, and underline the things you think are important. Okay, good. You accelerated from rest, so I'm going to underline that. That's important. 1.1 meter per second squared. 1.5 second race. Doesn't really need the race, but 1.5 second. What was his finishing speed? Cool. Pause it and see if you can figure out which symbols, these symbols right here, go under each one of these. Also see which assumptions you can make based on what I underlined. Pause it and try it out. That's the only way you learn, is by pausing it and trying. If you make a mistake, that's okay. I showed you the answer, but you have to try. All right. So from rest, I can assume velocity initial is 0. All right, you want to write that. 1.1 meter per second squared. Remember that the unit tells you what symbol to put. Meter per second squared, the distance over a time squared. Look, meter per second squared, you said that was acceleration. So that's what we're going to do, acceleration. For the 10.5 seconds, second is a unit of time, so it's change in time. It's nasty. What? That's a question mark. This is finishing speed. Finishing means last or final. Speed, velocity. All right. So we're trying to figure out what that is. Okay, that's all we're going to do for now. Okay, we'll come back and solve it and do all that stuff later. Okay, good. Next problem. Here we go. What I want you to do here, take these equations, not these equations, but take these word problems and see if you can solve these, okay? Do the exact same thing. Underline the important stuff and then put the symbols over it. Pause it and try it out. See if you can take about 30 seconds to do that. All right. accelerates. That's an acceleration, but be careful here. A lot of people want to say that this is actually the acceleration, but it ain't, right? It's not. What it is, look at that. What does that unit mean? Kilometers per hour. Look at your notes. Look at the thing we just wrote down. Kilometers per hour. That's distance over time. That's a velocity. Okay? Acceleration is a change in velocity, right? So if you're accelerating, that means you're changing your velocity. So this is velocity initial. This is velocity final, right? This collectively would be called your change in v, right? 3.2 seconds. That's a change in t. What is the rate of acceleration? What is the rate of acceleration? Is an equals, right? Did you get all these? If not, we got to get better, all right? Try the next one. Pause it and try this out. Okay, here it is. What is the acceleration? Right, so that's A equals question mark. Person who starts a 100-meter dash. So look at meter. Meter is a unit of distance. At rest. So what do I know about at rest? I can assume velocity initial is 0. Clock the end moving at 11.33 meters per second. Again, meters per second is distance over time. So that's velocity final, right? Because this is the end, right? Okay. Get all those? Hopefully you're getting better at this, not worse. Here we go. All right, try this one out. Pause it, try it. If you are traveling 45 meters per second, you hit the brakes to a stop. Brakes to a stop, that means you have a negative acceleration. And to a stop means velocity final is 0, right? Meters per second over here, velocity initial, right? It's a weird odd, but whatever. You will generate an acceleration of 15 meters per second squared. That's acceleration, but again, it's negative. How much distance are you going to cover? How much distance are you going to cover if it takes 3 seconds? Seconds is time, right? It's a change in t. You kind of getting the picture here? Great. Okay. Let's go back to let's try something else on that. Go back to the first problem. Mike ran a race. Okay, we don't have too much time here, so we're going to work this quick. What we're going to do now is we're going to actually write the equation that we're going to use to solve this. Okay? Here are your equations. You have them on your paper. They're right here. 1, 2, and 3. Keep in mind that this one can also be rewritten as v final minus v initial over change in t. We're going to simplify it. Okay, but change in t is equal to this. Okay, it's the same thing. All right, so keep in mind these are your equations you're going to use. Here we go. So I have to pick an equation that uses all these symbols, okay? And I can't have more than one missing variable. So look, the v final is missing, right? So pause it, take a look at your equations, and decide which one it's going to be. All right, let's try it out. The equation, the actual right equation is this one. Acceleration equal to velocity final minus velocity initial over change in t. Did you get that right? Well, look, check it out. This is how we know. Do I have acceleration in the problem? I do, right here, right? So check that off. I want to use red. Do I have velocity final? I do not, but that's what I'm solving for, so I'm going to put a question mark. I don't know it. Velocity initial, do I have it? I sure do, it was given. Do I have a change in time? I do. So if you are in a situation where you have all check marks except for one, you can use this equation. Right? You have to make sure it looks like this. You can only have one question mark. This is right. Let's imagine I use the other equation here. Let's say I use acceleration equals velocity final squared minus velocity initial squared over 2d, okay? So let's do the exact same thing. I have acceleration, I have velocity final, I have velocity initial, but I don't have displacement. And this does me no good because what else do I not have that I'm trying to solve? I don't have velocity final here. Where is it? I don't have it, so I cannot use this equation. Okay. All right, so try this on the rest of your problems and see if you get it. put the equation down, and go.